So the next method, number 3, is probably the quickest way, although I'm going to make it a little bit long at first, okay? But the reaction, this is, the formula is in your Princeton Review, it's in your regular chapter, and you've probably done it in Chem 1, okay? Its heat of reaction is heat of formations, the products, heat of formations of your products minus heat of formations of your reactants, okay? But in order to really understand this, we've got to know what a heat of formation is. First of all, I'd like for you guys to look on page 1112 of your book. I believe it's Appendix C. All right? You will see a whole bunch of delta HF values. Okay? Say again? Page number? Heat of formations of products minus heat of formation of reactants is the heat of the reaction. RXN meaning reaction. And actually, it's the sum. You guys know this little symbol, the summation symbol? Minus the sum. Okay. All right. So, let's look up the values. Can you guys look up the heat of formation for C2H5OH in the back of your book? It'll be under carbon.
C2H5.
C2H5OH. And there's 2 of them. There's a gas and a liquid. I want the liquid one. Everybody should be looking in the back.
Negative
277.7 kilojoules. And it's very important for you to look up the negative or the positive. Just write down whatever they have. Okay? All right. Now, before we look up any others, let's figure out what this means. What is a heat of formation? It is simply the heat of the reaction that produces a substance from its elements. What are the elements in C2H5OH? What's the first one?
Carbon.
Carbon. What's the next one?
Hydrogen.
Hydrogen. And what's the last one? Okay. Now, the other piece of the puzzle is it has to be the elements in their most stable form at room temperature. Let's start with oxygen. How does oxygen like to exist?
Gas.
Gas, and what else?
Liquid. I mean, not liquid.
Do we just write O?
O2.
O2. It's diatomic.
It likes
Right.
buddy.
So it likes a buddy,
Yeah.
and it's a gas. How about hydrogen?
Hydrogen likes a buddy and a gas.
Likes a buddy, and it's a gas. Now this one, carbon,
Likes to be solid.
it likes to be solid. Do you guys know all the forms of carbon?
No.
Okay.
Solid.
There's a diamond, that's pure carbon. There's graphite, what's in your pencils, right? These are not lead in your pencils.
There's
That
cold.
would kill us.
Okay, it would. We used to, you know what, Kayla told me that she read something that said lefties a long, long time ago when they used to, I mean seriously, if you take a piece of lead and you scribble it on paper, it writes. It really does.
Yeah.
Okay, so it used to be lead in the pencil, lead pencils. Okay, but lead absorbs through your skin and it's bad for your health. Evidently, lefties, when they write, who's a lefty in here? No, one. When you write, you drag your, right? Does your hand often get a lot of ink and stuff? Because the way she writes, it drags in what she's just written. Well, they said that lefties actually had more lead poisoning. Isn't that crazy? Now she said someone just told her that, so I'm like going to look it up because it totally makes sense.
It makes sense.
Most presidents are lefties.
Most presidents are lefties? That's kind of cool.
That's
Interesting. I know it. Okay, here we go back. So there's graphite, there's a diamond, there's buckyball, there's coal, there's soot. There's a lot of forms of carbon. The most stable form of carbon is what you're writing with. It's graphite. And of course, it's in the solid phase. Okay. The heat of the, oh, and we have to balance this. So,
2 carbon,
yeah,
6 hydrogen.
Nope, wait, that's not going to work.
2 here, 3 here, And I really want to keep this 1 mole because the value you gave me was kilojoules per mole, right?
So.
So what can I do to that oxygen? Doesn't look pretty, but
0.5.
yep, I'm going to do a half. Okay? So the heat of this reaction, which is a formation reaction, so we can put the F there, is negative 277.7 kilojoules. Okay? That's what a heat of formation reaction is. Elements to something, to some substance. Okay? Let's go ahead just for practice, not that it's part of having to do this products minus reactants thing. Let's write the heat of formation, or let's write a reaction for the formation of oxygen. We want to form a substance from its elements. What's the element in oxygen? Oxygen. What's the most stable form of oxygen? Diatomic and a gas. And of course this one we want is a gas.
Yay.
What do you think the heat of formation for this is?
0.
It's 0. There's no change, right? There's absolutely no change. Then the heat of formation is 0. Do me a favor, look in the chart and see if you see any other substances that have a heat of formation of 0.
Li solid.
Okay?
Aluminum.
Li solid.
F2.
F2, is it a gas?
Yeah.
Okay.
I2. Oh, no, never mind, never mind.
I2 as
Yeah.
what? There is an I2 that should be a 0.
Yeah, but
Which one
it's
is
solid.
it? Solid.
Yeah.
Which, okay. Cesium is a solid.
Iron solid.
Iron is a solid. Chromium is a solid.
Copper.
Look at mercury. What's mercury? As a liquid, it's 0. What you guys notice about all of these, and we could find more examples. What are they all?
What they're not.
0.
It's elements
Elements.
in their most stable form, right?
Yes.
Of course.
Anytime you have to look up the delta H for an element in its most stable form, it's going to be 0. That's a very good thing to know because you're not expected to memorize these numbers, just to use them. Oftentimes on the AP exam, they will give you a chart of what you need to know. But guess what they'll leave off?
0.
They'll leave off anything that has a 0 value because you should know that elements are 0. So those people who don't know that, they're going to pick letter D, not enough information to tell. But those who do know that elements are 0 are going to proceed with their problem and get a number. Okay? So you got to know that. All right, here we go. Let's real quick write a heat of formation reaction for CO2. What are the elements in CO2? Carbon and oxygen. We know oxygen likes to be diatomic in a gas. Carbon is solid and graphite. Okay? What's the value for CO2? Negative 393.5 kilojoules.
Yeah.
Okay, last but not least, if we want to form water, and in this case we do want a gas, because there'll be a value for the liquid in your chart as well. This is hydrogen and oxygen. How do hydrogen and oxygen like to exist? Diatomic
Together.
and a gas. Diatomic and a gas. To balance this, the hydrogens are fine. I'm going to have to do my half trick again with oxygen, aren't I? What's the value? I believe water is under oxygen. It's always under one of the elements in the compound. Can anybody tell me the value?
-285.83.
Make sure you're looking up gas.
-241.8.
Yeah.
Negative 241.82. So just always pay attention to that. Okay. Does everybody understand what I've been doing?
Yeah.
Okay. Now, really, let's go back to method 3. I've been kind of a stinker butt, and I've been actually setting us up for method 4. But let's go back to method 3. All we really had to do in method 3 is look in your chart and look up the value for each of these. This is all we had to do. We didn't have to write all those reactions. But sometimes you're asked to, and I wanted you to know it. Okay, so now we're simply going to do products minus reactants. But keep in mind that all of these values are per mole. So we're going to have to incorporate our coefficients. We start with our product. Our first product is our CO2. So we're going to have negative 393.5 kilojoules. And what are we going to multiply that by? 2. There's 2 moles of that. So for each mole is 393.5. So for 2 moles, we're going to multiply by 2. And then we're going to add to that our water, which is negative 241.82. And how many moles of that do we have? 3. Okay? So what you've just done right here is this is the sum of the heats of formation of your products. So we've done the first part of our formula. Now we're going to subtract from that our reactants. Our first one being our ethanol, negative 277.7 kilojoules. How many moles? Just one. And then our second reactant is oxygen. Even though it's a 0, I'm going to write it down just because you guys, for this model, you don't have to write it in the future. But how many moles? 3. Okay. And so what you've just done here is this is the heat of formation of your reactants. So you're going to take all of this, add that up, and then you're going to subtract all of this.
And then technically you don't need summation.
Right.
This one
Okay.
looks exact.
And so this one's probably the most exact. Yep. Okay. Y'all tell me what you get as your answer.
So you're saying that a problem like this, it will never be the answer needed?
No, I'm not saying that, silly dude. Good try, getting that little hint.
1234.
1234.76?
What's that?
Okay, so I'm going to round that to 1235. Did you guys get a negative sign?
Yes.
This should spit out the right sign. In calorimetry, you have to decide, but in all the other methods, in method 2 and method 3, it gives you the number and the sign. Brandon.